Alright, well, that was a mess. Alright, so welcome back to the second lecture of this break. Please let me know real quick how the volume sounds on this. I learned it was using the wrong mic, so I fixed that. Hopefully it sounds better. So let me know real quick. Or real slow. I don't know how bad the lag is right now. Okay. All right. So today we are talking about the hyperbolas. So hyperbolas are kind of like a cousin to the ellipse. It has two focus points, but if you notice, the focus points are actually on the outsides of our vertex. So our two focus points that we're going to have is on the outside of our vertex, unlike ellipses last time, where the two focus points were inside of the major endpoints of the axis. All right. So one thing you may notice that's going to be a little bit different is that we still have this like minor axis looking line, but it doesn't actually touch the hyperbola at all. So we're going to talk about that a little bit later. But to make a hyperbola, so last time you saw that I could draw an ellipse using a string because that string, that same distance, no matter where I was a constant sum. This time, if you pick 2 points on a hyperbola, or pick a point on a hyperbola, the distance from both of the focuses are going to be a constant difference, meaning we subtract the two. So if I took this distance right here and subtracted it using this distance here, I would get the exact same value if I had done it way over here as well. So that is making a hyperbola. So I'm also going to, a little bit later, teach you how to draw these. They're not that bad. They actually have asymptotes. So we're talking about those asymptotes a little bit later. Alright, so I don't know if you guys actually went through the notes or not. More likely you did not, but on it there is a GIF about the how we can turn basically like a circle into a hyperbola by moving our focus points outwards. So up at the top you can see that we have this E number, that is the eccentricity value. So we talked about that last class. So as it gets larger and larger, once it surpasses 1, it actually becomes outside of the vertex because our C value is the distance from the center to the focus, and our A value was that center to the vertex. So as C was moving further out, it at one point passed our vertex, and that's why it was starting to be greater than 1. So if you haven't looked at this GIF, I highly recommend it. And no, I will never say GIF, so deal with it. So this time around, we're going to have a slightly different equation. We are going to start with x squared over a squared minus instead of plus. So that's going to be huge, that minus instead of a plus, because unlike last time with addition, it doesn't matter a plus b is the same as b plus a, but a minus b is not the same as b minus a. So it's going to be very important which term is first. So if you've already looked through the slides, you'll notice that our a squared is always the very first underneath the denominator of our first one, and our x's and our y's were the ones that we're switching. So I'll talk about that a little bit later as well. So the only big difference is that we have a minus instead of a plus going from the ellipse to the hyperbolas. So to iterate some new terminology, so this line right here from that focus to the other focus is what's called the transversal axis, the transverse axis. So it is going to be you can think about it like a major axis. So we have this major axis going from the focus to the other focus. We also have the conjugate axis. So our conjugate axis is going to be this piece right here. So this is your conjugate. So notice that that is not touching any part of the hyperbola, nothing at all. But it is going to be important for us because it helps us determine our asymptotes. So again, just like last time, our A value is going to be the distance from the center to our focus. So this right here is going to be our A value. Our C value is going to be from the center to our focus point. So again, that's C. And from this imaginary point up here, it's not actually imaginary. We talked about complex numbers, but it's just a point out over somewhere on the plane. It is our B. So again, this B value is going to be important for us because it's going to help us graph them. It's also going to be important to help us find C, help us find A, depending on what the problem is asking for. Because again, there is going to be another Pythagorean identity here. Okay. So let's quickly talk about sketching them. It's going to be kind of straightforward with sketching. Alright, so let's imagine that our center is at the origin. And I'm going to say A is going to be the value of 4, B is going to be the value of 3. I'm just making these up. I'm just going to show you how to graph it. We'll learn all about this later. Just stay with me for right now. I made that up. These are not anywhere on the notes. Made it up. So right here will be my center. So at the origin. I'm going to say that this is going to be a horizontal. So it's just going to open up horizontally, left and right. So that means that I'm going to be going a distance of 4, 1, 2, 3, 4, out on both directions for my A value. My B value is going to be perpendicular to that A, just like B was perpendicular for our ellipses. So that means I'm going to be going up 3. I'll be going down 3 as well. So what I'm going to do is I'm going to actually make a box just like with our ellipse. So if you remember last video that we actually drew an ellipse, we made a little box and then we connected on the inside. Here the hyperbolas go outside of the box. The cool thing about this box though is if you draw the diagonals and continue out in both directions, those are actually your asymptotes. So if I draw my diagonal for both of these, then my hyperbola is just going to look like this. So again, they're going towards those asymptotes, just as, again, most things go towards the asymptotes. And we're hitting A's because A is our vertex. A is always a vertex. So we're actually hitting that A. So the B actually helps define how wide or how skinny these things are actually going to be. Okay. So, any questions right now before we move on to the actual formulas, talking about the formulas a little bit and then doing some examples? Today should be a little bit quicker. So let's go on to the slide that had a bunch of information. Again, just like the parabolas and the ellipses, the hyperbola has a bunch of different characteristics as well. The important piece this time around is, again, we have a subtraction instead of an addition. And also our Pythagorean relationship is going to be slightly different than the ellipse. So that's going to be important. So our focus is actually the furthest point out. So if I had drawn a focus point, let's say it's right here, that means that that distance, I'm going to use colors again, or maybe, probably not, nope, not using colors. So the distance from here to here was C, so that means this is actually going to be my my hypotenuse of my triangle, where over here is my B value, over here is my A value. I could lay out this whole length of C and it would become my hypotenuse of that triangle. So this time around, we're looking at a relationship of C squared equals A squared plus B squared, which is what you were all used to. So with the hyperbolas, it is the exact same Pythagorean relationship as what you're actually used to using A, B's, and C's. So please note that this one is for your hyperbolas. For your ellipse, it is A squared equals B squared plus C squared. So an ellipse, alphabetical. For your hyperbola, it's what you're used to. So please note that there are two separate relationships depending on which one you are actually working with. Because C is the furthest, the largest distance, so that's why it's going to be your hypotenuse. And with your ellipse, the focus was on the inside, so that's why it was a shorter distance from the center. Okay. So there are also some equations for your asymptotes. So if you actually look at these asymptotes, you'll notice that it has a slope. And that slope is going to be, you had to go up some distance of B, and then you had to go over some distance of A, so that's why you're seeing the B over A for these horizontal, and because there's two of them, that's why you have a plus and minus. And then, of course, since that's your slope, that's whatever it is in front of your x value, because again, y equals mx plus b, m is your slope, so your slope is just this b value over this a value. So that's where it is coming from. That's why it's in the equation as such. You'll see later as we move things around, you're still going to see those exact same slope values. Just where you're located is slightly going to be different. So let us try an example. So again, this is going to be our key equation, but it matters which one is in first. So I guess let me talk about that quickly before we do an example. All right. So this time around, it does not matter which denominator is larger at all. It does not matter. A is just always going to be under the first term. B is always going to be under the second term. So A and B, it does not matter the size difference this time as it did with the ellipse. That does not tell us any kind of information. So A and B doesn't tell us the shape or direction at all. I mean, it does tell us the shape, but it doesn't tell us the direction that these are opening in. What matters is what is the first term up here. So since our x is in the first term, this is going to be horizontal. So we're going to get out the hyperbolas that look like this. If our y squared value was first, notice again, A is still under the first term, B is still under the second term. If your y is ever the first term, this is going to be vertical, meaning it's going to look like this. So again, it does not matter for a hyperbola which is larger. A and B can be different values. They can even be the same value. So that's important to note. A and B can be the exact same value this time around. Whereas last time that didn't make any sense, because then you would have actually had a circle going on. So with your hyperbolas, it doesn't matter your A and B at all. A is just always under the first term. B is just always under the second term. All right. So let's get into an example, figure out what we are working with. All right. So our first problem, we are given 4x squared minus 9y squared equals 36. So we are asked to find the vertices and the foci of this problem. So if you notice, this is not in the right format right now. It's not in the right format because I need this value over here to equal out 1. So I need to make 36 into 1. And the only way to make 36 into 1 is to divide everything by 36. So that's going to be my first step, is just to make it into 1. So whatever's going on over here, I don't care about right now. I need to make this value a 1. So I'm going to divide everything by a 36. And also note that in our equations, we don't have any coefficients in front of our x's or our y's. Everything is in the denominator. So that means we need to simplify these fractions even if we can't simplify them. We just have to do it. So that means that when I simplify this, I get x squared over 9 minus y squared over 4 equals 1. So now we're in something that we can work with to find all kinds of information. So because x squared is first, we know that this is going to be a horizontal. So because our x squared is first, this is telling us it's going to be horizontal. So my a value is always underneath my first term, but this is really a squared. Just like over here, my second term, this is really b squared. So I can find a and I can find b. So a is going to be 3, b is going to be 2. So now that we have that 3 and we know it's going to be horizontal, and also because again this is going to be at a center of 0, 0. So I have a center value and it is at 0, 0 because that is what we are currently talking about. So I need to move left and right a distance of 3, and that will find me my vertices. So this will help me go, so if I go 3 in this direction, I will find this vertice. If I go 3 to the left, I will find the other vertice. So that means I'm going to take, just like last time, where we used our center, which was 0, 0 this time, I need to go 3 to the right and I need to go 3 to the left. And going 3 to the right means that I'm going to be adding or subtracting to my x values. So my y value is going to stay the same. So this is actually going to be positive 3, 0 and negative 3, 0 for my two vertices. So we saw that our vertices were at 3, 0 and negative 3, 0. So now I just need to find my focus. So with an ellipse, we also had those co-vertices, those other vertices that were using B, but notice that our B value doesn't touch anything, therefore it cannot be a vertice. B is only there to help us determine the width of our sketches. It is also going to be useful to help us find C because of the Pythagorean relationship, but it does not help us with anything else other than sketches. So B is just by itself until we need to help us find those focuses, which use C. So I need to go and find my C value. So again, C squared equals A squared plus B squared. So this is just going to be C squared equals 3 squared plus 2 squared. So I get out C to equal the square root of 13. So again, 9, 4, added those together, 13, took the square root of both sides to get the square root of 13. So we now know what C is. So our C value, our focus, is also going to be horizontal because they are inside of our hyperbolas. So they're inside of them. So it's also on this horizontal line, which means I'm going to be adding and subtracting this square root of 13 to the center's x value again. So again, I have a center, which was 0, 0. I'm going to be adding the square root of 13 and subtracting the square root of 13 to get my focus points. My y value stays the same because again I'm only moving horizontally from the center. So these are my two foci. So again, if you are an on-level pre-calc kid, you can tell me what the square root of 13 as a decimal, rounded off to the hundredths. If you are one of my accelerated kids, I better see the square root of 13 in an answer somewhere. Give me exact values. So again, let's go over everything we just did. So the first thing I needed to do was I needed to change my equation to make it into the proper equation, which means I needed to get a 1 of what it was equal to. So I divided everything by that 36. I simplified the fractions because I don't have any coefficients right in front of my x or my y. So then a squared is always the first term, so that found me to be a to be 3. B squared is always the second denominator, so that found me a b to be 2. Since x was my very first term, that was telling me this is going to be horizontal, meaning it's going to open left and to the right. So because my center was at 0, 0, all I had to do was add and subtract that a value to help me find my vertices to the x, because x is horizontal. So I was adding and subtracting that distance of 3 because there's two vertices, one to the right, one to the left. So add 3, subtract 3. Then I needed to find my C value to help me find my foci. So I used that Pythagorean relationship. I simplified it and found C to be the square root of 13. I did the exact same thing because my foci is on the exact same horizontal line as my vertices. I added and subtracted it to that center at 0, 0 and only added and subtracted to the x value, keeping my y's the exact same. So I'll give you a couple seconds to digest. I will look to see if you have any questions, and then we will move on to the next example. So let's move on to the next example. Alright, so the next one says find the equation for a hyperbola that has a focus of 0, -3 and 0, 3. So we know we have a focus, which is again referring to any kind of C value. We have one at 0, -3, and we have one at 0, 3. We also know that the conjugate axis, so our conjugate axis, think about this as your minor axis as last time. So this is referring to your B, has a length of 4. Alright. So this time around we don't have an equation yet, so we are going to be using this information to help us find that equation. So just like I would normally say, given information, let's sketch it to kind of help us determine what pieces of information we need to help us determine which equation to use, yada yada yada. So we can do a quick sketch of our two focus. So we have one at 0, -3 and one at 0, 3. So that means that we have a focus here and here. So because we have two focuses that are vertical, that means our hyperbolas are going to be vertical because our focuses are inside. So notice again that I drew them inside of these little parabola looking things. So we also know that the conjugate axis has a length of 4, which is nice because this is the same kind of concept behind our ellipses when we were doing minor axis. Where our minor axis was the length of 2b, our conjugate axis is also the length of 2b. So that means that 2b equals this 4, so that means that b just equals 2. So we know that b equals 2. We need to find a still, and we know that it's vertical. So because it's vertical, I know that my y term has to be first. So this is going to be the y squared over a squared minus x squared over b squared equals 1 equation. Because it's vertical, because my foci were on a vertical line. Vertical, y. Horizontal would have been an x. So now I just need to go and find pieces of information. So again, we can find the center because the center is just the middle of our focus. But again, right now we're just doing a center at 0, 0. So if you really wanted to, you can find the center of this and you would have found it to be at 0, 0 for our center. So why do we need the center? Because everything goes out from the center. Our length of B goes out from the center. Our length of A goes out from the center to our vertices. Our length of C goes out from the center to the foci. So that's what we're going to be finding right now. We can find our C value because I have a focus. Because again, foci means C. So I can find C by finding the distance from the center to one of those 2 points. So I'm finding my distance. So this is to help me find C. From the center, which was 0, 0, to one of my foci, it doesn't matter which. Again, it's distance, make it positive. So 0, 3, so the distance, so these zeros don't matter because they are the exact same. So the distance from 0 to 3 is just 3. So my C value is is 3, and I found that by finding the distance from the center to the foci. So now that we have C and we have B, I can use that Pythagorean relationship of C squared equals A squared plus B squared to help me find my A value. So I'm going to be plugging in both C and B to help me find A. So C was 3, so this is 3 squared equals A squared plus our 2 squared. So this is 9 equals a squared plus 4. Subtract that 4 over, and I get a squared equals 5. So again, I could take the square root of that, but a squared is already in the equation. So that means I already have what a squared was, which was 5. So I can just use that and plug that into the equation as it already is. So since we have a, we have b, we're done at this point. So this is y squared over a squared. We just found a squared to equal 5 minus x squared over b squared. So our b was 2, so 2 squared gives me 4 equals 1. And we're done. Here is our equation for this problem. So again, to reiterate, we were given a focus and a conjugate axis length, which you can think about as your minor axis length. Your foci refers to your C value. Your conjugate minor axis refers to your B value. So we use the fact that 2B equals your conjugate axis. So I set 2B equal to 4. I found B to equal 2. I also sketched out the 2 points I was given, and I noticed that they formed a vertical line. So I knew that this was going to be a vertical hyperbola. So after I did that, I knew since it was vertical to make sure my y squared was first and my x squared was second. I then found my C value, which is the distance from the center to the focus. So I found the distance from 0, 0 to 0, 3 to give me out 3. So then I used the Pythagorean relationship of c squared equals a squared plus b squared to help me find a squared. And then I just plugged in a squared into the equation, and I squared my b value to get 4, and I was done. So again, I'm going to give you some time to look at this real quick. Then we will go on to the next, and the next piece is when our center is not at 0, 0. So we can now do this wherever our center may be, but you're going to see that we're going to follow the exact same things. So we're going to need to find our center first to help us find everything. So again, have some time. All right. All right. So on the next slide, if you haven't already written everything down, these are all your equations that have your center at any point, so HK. So you could have the equation x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. Or you could have the y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. So again, some important pieces. Whichever one is first, so my x was first, that means this one's going to be horizontal. My y was first over here, so this one's going to be a vertical one. Your x value of your center, your h value, always goes with x. Your k value, so your y value of your center, always goes with y. So no matter where it is, so y, k, x, h. So x with x, y with y, always. Also, again, this is like the 20th time. The minus sign is built into the equation. So you need to be aware that that minus is being built into the equation, which means it's going to be the opposite anytime you have to pull something out. Okay. So, you'll also notice that you have your asymptotes are going to be, again, just the transformation notation for a linear line. So for this one, it would be y equals plus or minus b over a x minus h plus k. And then the other one is just a over b instead. So this is just those two lines that are your asymptotes that will define the shape of your hyperbola. Again, they're just using those center values to be able to move your line from the center up, down, left, right. So that's why you have the minus, and that's why there's still a plus, because again, you can think about that IHOP that we talked about. Inside is horizontal and it does the opposite of what you think. Outside is vertical and it does what you expect it to do, etc., for OVEX, IHOP. All right, so let's do an example. So it's going to be the exact same process. So remember with an ellipse, when we had a center somewhere other than 0, 0, we had to find that center first because that helped us find A and B and C or whatever we needed to be able to fill out any kind of information. So let's try an example. So we are given an equation to start with. We have x plus 2 quantity squared over 9 minus y minus 5. All right. So we're given the equation x plus 2 quantity squared over 9 minus y minus 5 quantity squared over 49 equals 1. We are asked to find the center. We are asked to find the vertices. And we are asked to find the foci. So again, there's a pair of vertices, there's a pair of foci. The b value, it's not going to help us find any points because it is not actually on the hyperbola. So let's start by pulling out the center. So again, there is a minus already built into the equation. So what I'm pulling out is going to be the opposite of it. Also, your x goes with x, your y goes with y. So I'm going to be pulling out a negative 2 for the x of my center, and I'm going to be pulling out a positive 5 for my y value of my center. So now that we have our center, we can then go and start finding other things. So one thing we need to know is that since our x is squared, this is going to be a horizontal one. So this is horizontal because my x was my first term, so horizontal. My a value is coming from this first term's denominator. So this is again a squared though, so that gives me an a of 3. my b is always coming from the second term, but it's b squared, so therefore b is 7. So, since we have a and b, and we're asked to find the foci, we might as well go ahead and just find what c is. So, again, c is just going to be your c squared equals a squared plus b squared. So, finding c. So this is c squared equals 3 squared plus 7 squared, which gives me c squared equals 58. So let's see. No. So this is just c equals the square root of 58. So again, you can write it as a decimal if you're on level, accelerated, keep it as that square root of 58. In my opinion, it's actually easier to keep it at the square root of 58, but whatever. It's my opinion. So let's start by finding our vertices first. So again, I need to use that center value. So my center was -2, 5. Since this is horizontal, because my x was the first, that means I'm going to be adding and subtracting values to the x term. And what am I going to be adding and subtracting? I'm going to be adding and subtracting my a value, because your vertices refer to your a value. So I'm going to be adding 3 to this, and I'm going to be subtracting 3 to this, and just the x value. So my y value stays the same, so my first one gives me 1, 5, because it's -2 plus 3 is 1. And -2 plus -3 gives me -5, 5. So these are my two vertices. Because again, I have to go out from that center value, and since this was horizontal, I'm going left and right those values. So that means I'm adding and subtracting it to my x value. So the last one is I just need to find my focus. So since you're finding your focus, again, or foci, this refers to your c values that you found. Again, we're just going left and right from our center value. So everything goes from the center. So, because it's horizontal, I'm going to be doing this to my x values again, so that means I'm going to be adding the square root of 58 and subtracting the square root of 58 to my x values. So what I get is -2 plus the square root of 58, 5, and I get out -2 minus the square root of 58, 5. Again, those are not like terms, you can't actually add them, so just keep them separate. And that's why I think this is easier than having to add those decimals together, because that means you got to get out your calculator, more likely. So, again, we're done at this point, because we just found this to be -2 plus the square root of 58, 5, and -2 minus the square root of 58, 5. So, I'll talk over it again real quick. So, we were given this equation. We were asked to find our center, vertices, and our focus. So our center is going to come from our h and k value. So our x is always with x, our y is always with y. They're the opposite. That is why you see a -2 and a +5. My a comes from my first term's denominator, so it's the square root of whatever that value is. B is the square root of whatever the second term's denominator is. Then we just went ahead and found c, because we needed to find our focus, or foci. So c squared equals a squared plus b squared. So I went and I simplified, and I got down to the square root of 58. So then for my vertices, I take my center point. Since this was horizontal, again, that's an x value change. I'm going to be adding and subtracting my a value, because that's my vertices. From my x value of my center, I added 3 and subtracted 3. Kept my y's the same. For my foci, I did the exact same thing, just using my c value instead, because my foci is the c value. And that was it. So again, I'll give you a couple seconds to digest this, and then we only have one more example left, and then we are done for today. So I had a question about sketching. So I can sketch this. So I'm going to sketch this real quick just so you can see that it's not too bad. So over here, I'm going to sketch this. So my center was at -2,5, which I'm going to say is about right here. So just like with my vertices, how I went right and left that 3 value. So my A value was over here and over here. My B value was 7, so if I went up 7 and down 7 from this, it would be something like this. I can then draw a box with those 4 points I just drew, and I can connect through the diagonal to be my asymptotes. And here was my vertice, here was my vertice, so this was horizontal, so it would look something like this. Notice how wide it is, and it's wide because B is so much larger than your A value. Alright, so doesn't seem like there's very many questions, so we'll just move on to the last example. Before we move on to the last example, I just want to quickly talk about recitation. So our first recitation is going to be tonight around 5 o'clock. What that's going to look like is we are going to do a Zoom call. It's going to be a video conferencing call. That way you guys can all ask questions. You can show me pictures of your questions, whatever it may be. That way it will just be an hour to an hour and a half-ish of you asking questions. Maybe we can do a couple more examples, so forth and so on, for you guys to all understand it a little bit better. So yes, hopefully you all saw the note also about the quiz corrections on those two previous quizzes. I highly recommend doing those because literally what else are you doing with your life right now? I'm trying to think about how to do test corrections. I have some ideas on those. I may try to test out that idea with the few of you that were doing the test corrections for the matrices where you only had like a question or two left. Or see how that goes, and then I can do that for the vector test. I think that's pretty much all of the announcements. Again, make sure you're keeping up with this work. I am going to be collecting it. I'm going to ask you guys to send me pictures of it or something, scan it, whatever, because again, I have to be giving you grades for this. You need to just pretend like this is actual school, because otherwise you may not graduate, because we may be here for the rest of the semester doing this exact same stuff, so we need to be working together so we can still get you guys to graduate, my 12th graders. Alright, so last equation, or last problem. So find the equation of a hyperbola whose transverse axis has endpoints at, so we are given a transverse axis. So your transverse axis, you can think about that as your major, which means this is going to help you find A. So those 2 points were -2, -1, and 8, -1. We are also given that our conjugate axis has a length of 8. So again, think about this as your minor axis. So that means this is going to help us find B, and it's a length. So the length was 8. So a couple things. Go ahead, just sketch those 2 points real quick. So sketching those points. So -2, -1 is going to be somewhere about here. 8, -1 is going to be somewhere over here. So you can see that this is going to be a horizontal because it's on a horizontal line. And your transverse axis is your major axis. So we know this is going to be horizontal because, again, these points are horizontal to one another. And this is your A value. These are your major, these are your vertices. So we can also go ahead and find B because this is, again, a length, and this is the minor. So this is going to be 2B equals 8. So B equals 4. So I know that, I don't know what A is. I know that B equals 4. I need to still find my center. And I also now know, since this is horizontal, this is going to be the x being first equation. Oops. All right, so we have B, I need A, and I need to find the center. We can find the center because, again, the center is just the middle of any points that we were given. Again, as long as those points were the exact same. So I need to find the average of these two. So again, using my midpoint formula, so I'm going to go and find my center. I can use that midpoint formula. So that means add your x's together, so -2 plus 8 over 2, and add your y, so -1 plus -1 over 2. So this gives me 3, -1 as my center. So the point 3, -1, which is about here, is my center. So the last thing I need to do is to find my A. So A is just the distance from the center to that major axis, your transverse axis endpoints. So we can do that. I can find that distance. So to find A is just the distance from the center, which was 3, -1, to one of my vertices, which doesn't matter which one you do. I'm going to choose 8, -1. So just again, it's distance, make it positive. So the -1s are the same, so that's not going to affect my distance. So 3 to 8 is 5. So my A value is 5. So we now have all pieces of information. We can now just plug it all in. So this would give me x minus 3 quantity squared over A squared, so 5 squared is 28, minus y minus k, so y minus -1 gives me y plus 1 squared over B squared, so 4 squared gives me 16, equals 1, and we are done. So, done. So, let's talk over it real quick again. We were given the transverse axis endpoints, which are your vertices. Transverse axis is also your vertices. I'll write that down. You can think about it as your major axis. Just all of these words should mean A to you. So we were given those 2 points. Your conjugate axis, also think about it as your minor axis. We were given a length, so this helps us find B. So we know that the length of the conjugate axis is 2b. So I set 2b equal to 8. I found b to be 4. When I drew a sketch of those 2 points, I saw that they were on a horizontal line, which means they are going to be opening horizontally. So because they're opening horizontally, I knew to make sure my x was being in the very first term. We found the center by finding the average of these 2 points, so using midpoint formula. I average my x's, average my y's to get the center. Then the last thing, I just needed to find a, and a is the distance from the center to one of your vertices. So I found the distance between these 2 points. So the negative 1's were the exact same, so they didn't matter. The distance from 3 to 8 is 5. If you even went the other way, 8 to 3 is negative 5. Make it positive, positive 5. So I then plugged in the center, A and B, into my equation, and I was done. So, is there any questions? Again, we have recitation over this, so at least start trying some of these problems before tonight. We can talk about parabolas, we can talk about ellipses, we can talk about hyperbolas all during that time. It doesn't matter. Just ask a question during recitation and we will get it handled. Again, probably only have like an hour, maybe an hour and a half to be doing that around 5 o'clock tonight. So look over this, ask your questions if you have any, and we will be done for the day. Alright, so we only had about 40 people watching this stream, so make sure that your friends are doing something. We are still going to have tests and whatnot. I'm still trying to figure out that process, but they will occur, and it will occur before we get back. So make sure that you are all keeping up with this. It is not a joke. This is not a break. This is not spring break yet. When spring break actually occurs, I will not be doing anything because that is an actual break in the calendar. That means I'm not going to be teaching during that period. So just be aware of that. This is not a break. Spring break is a break. So don't treat this like a break. Otherwise you will get too far behind. Trust me, you do not want to be too far behind. So, bye.